Alright, section 7.1, we're going to study quadratic functions in vertex form. Quadratic functions come in two different forms. There's what we call vertex form, and this looks like this, and we'll see in just a few minutes here why this is called vertex form. This is what we're going to study in this section. And then they come in standard form. And this will be the topic of our next section, section 7.2. And what we're going to look at mostly in section 7.1 and 7.2 is graphing these kind of functions. Now, the first important thing I want to point out, for both of these I have to have a cannot be 0. The important thing I wanted to point out is these are not linear, and this is why I had to have a can't be 0. These are not linear because we have, in each case, an x squared. So we know the graphs of these are not going to look like lines. The graphs of these are going to be something called a parabola. So let's start with the most simple quadratic equation, y equals x squared. And what I'm going to do is I'm going to build myself a little table here, and then I'll use the table to draw a graph. So I'm going to plug in my favorite numbers for x. I'm going to plug in 0, 1, and 2, and then I'll plug in a couple negative numbers, -1 and -2. When I plug in 0, 0 squared is 0. I plug in 1, 1 squared is 1. I plug in 2, 2 squared is 4. I plug in -1. -1 times -1 is +1. And then when I plug in -2, -2 times -2 is +4. So I get something like this. I get 0, 0. I have 1, 1, 2, 4. And we see right away that's those three dots are not in a line. We didn't expect a line. That's okay. -1, 1. -2, 4. And we get this shape. And this shape is called a parabola. Now, there are a couple important things on this parabola. There's this point right here, which is the lowest point on the parabola. That's called the vertex. And that's going to have a lot to do with our thing called vertex form. You might notice that in this case, this vertex just happens to be the x-intercept and the y-intercept. That's not always the case. But those are things that are going to be important to us as we look at more and more at parabolas, are x-intercepts and y-intercepts. But the most important point on any parabola will always be this one right here, called the vertex. Alright, so now let's see what happens when we change the equation just a little bit. Let's say I have f of x, which is y. Let's say I did x squared minus 2. So what's a minus 2 going to do to this graph? Well, again, I might build myself a little table, draw myself a little graph here. And again, I guess I'll pick my favorite numbers. I'll pick 0, 1, and 2, and -1 and -2. When I plug 0 in, I get 0 minus 2, that's -2. When I plug 1 in, I get 1 minus 2, that's -1. When I plug 2 in, 2 squared is 4, 4 minus 2 is 2. And then when I plug in -1, -1 squared is 1, 1 minus 2 is -1. And when I plug in -2, I get -4 minus 2, that's 2. So you might start to notice a pattern in the numbers here. I got a 1 and a 4, I got a 1 and a 4. Down here, couldn't quite see it all, could you? Down here, you notice I got -1 and 2, -1 and 2. There seems to be a repeat in the y values all the time. Not a coincidence. Alright, so we have 0, -2. We have 1, -1. We have 2, 2. We have -1, -1. And we have -2, 2. I get my parabola. Now, what should have happened if I had done my scaling nice and equally compared to the graph up above? You should see that these are actually exactly the same shape. All that's happened is this -2 right here took the vertex and slid it down 2 places. Otherwise, it's the exact same graph. Now, let's take a look at a couple on our calculator here and see if that continues to happen. I think it will. Can't see that very well, can you? All right. What if I have y equals, I'm going to have x squared, and then I'm going to do x squared plus 3. Now, just a minute ago, when we had a -2 right there, we saw that it shifted the graph down 2 places. Should be a reasonable guess that this plus 3 is going to move the graph up 3 places. Let's take a look. There's the x squared, and there's the x squared plus 3, and if you notice, 1, 2, 3, it went up exactly 3 places. Okay, so there's our first thing about these equations in vertex form. If I have f of x equals a times x minus h squared plus k. What we've seen so far is the k moves the graph up k units when k is positive, and down k units when k is negative. Alright, so a quick question I might ask. I'm going to leave some space here because in a minute we'll figure out what h does, and then in a minute we'll figure out what a does. So I'm going to leave some space. So, for example, just a quick problem, if I were to give you y equals x squared minus 4, what you should tell me right away is you see that this minus 4 is here. That's going to move the vertex down 4 places. So right away, you should know the vertex is the point 0, -4. So when you go to graph, there's 0, -4. And now I'm going to build my table. If I pick 1, plug in 1, I get 1 minus 4, that's -3. When I plug in -1, I should get exactly the same answer. If I go 1 space to the right of my vertex and 1 space to the left of my vertex, you get exactly the same y value. And that's that property that we saw before. If I plug in 2, I get 4 minus 4, that's 0. So I know without doing any work, when I plug in -2, I'm also going to get 0. And that's what we call a symmetry property. When we're dealing with parabolas, we have a nice symmetry property. And that property is, if I could cut my piece of paper right along there, right where the vertex is, and fold it over, I would have exactly the same picture on both sides. Alright, now let's take a look at h. And we'll come back to that page in just a minute. Let's say I have y equals x minus 1 squared. And I think the easiest way to convince you of what's going to happen is to look at our calculator. So here's y equals x squared, and then we're going to have x minus 1 squared. Now we saw that if we put a number outside of these parentheses, that moved the graph up and down. A reasonable guess would be a number inside the parentheses is going to move it right and left, and that would be correct. The thing is, it moves it opposite from what you would probably think. And here's what I mean. There's x squared. Notice that that minus 1, that x minus 1, moved that graph 1 space to the right. If I change it to an x minus 3, there's x squared. The x minus 3 moves it 3 spaces to the right. And the reason is, think about your table here. we're not moving the graph up or down, we're moving it left and right. So where is this graph going to hit the y-axis? Where is it going to be 0? It's going to be 0 when x is the number 3, because 3 minus 3 gives me 0. Alright, so h moves left and right. If you have x minus a number squared, you move right h units. Where maybe instead of number I should have put h there. Conversely, we'll see this in just a second, if you have x plus h squared, you're going to move left h units. And let's just do a couple examples of that on the calculator. Let's just change that to a plus 3. Shouldn't be any surprise. It goes 3 units to the left. Okay, so here's what a typical homework problem is going to look like. I might give you y equals x minus 2 squared minus 1. And what I will ask you to do is I will ask you to find the vertex, and then from there draw me a graph. Well, what you should notice is our vertex is normally the point 0, 0, except we have x minus a number here. X minus a number moves the graph to the right, which means our x value has to be 2. X's go right and left. This number out here moves the graph up and down. Since it's negative, it moves it down, so our y value has to be negative 1. So we know we have the point as our vertex 2, negative 1. Now I'm going to build myself a little table here. I'm going to go one space to the right of my vertex, which means x is going to be 3. If I plug in 3, I get 3 minus 2, that's 1. 1 squared is 1. 1 minus 1 is 0. So I have 3, 0, which without doing any work tells me I also have to have 1, 0. Again, if I go one space to the right of my vertex and I get my y number, that's going to be exactly the same as going one space to the left of my vertex and getting the y number. And then I'll do 2 more numbers. Now I'm going to go 2 steps to the right. If I plug in 4, 4 minus 2 is 2. 2 squared is 4. 4 minus 1 is 3. So again, without doing any work, I get another point. So I get the point 4, 3 and the point 0, 3. Alright, so here are some problems for you to end this video, and then we'll go on to part 2 here. So homework. For each of the following, I want you to find the vertex and then graph. And let's see, we'll have y equals x squared plus 2. Y equals x plus 3 squared. Y equals x plus 2 squared minus 5, and the last one, y equals x minus 3 squared plus 1. Okay, so do what I did. Find the vertex. Use your shift up and down, shift left and right, and then build yourself a small table. Draw a graph.